Okay, so this picture that is at the top of your packet and these vocab words that I've started with already should sound familiar. What is that a picture of at the top of your page? Yeah, that's the water cycle. As it says at the top of the page, it is officially called the hydraulic cycle. So it's still talking about water. The first four words, like I said, I think you should know them. Obviously, I'm pretty sure you knew evaporation. That's the water coming out of the ocean and going up. Transpiration, I do think you learned, I know you learned it last year, but you probably had forgotten that word. I like to call it plant sweat, but the process of photosynthesis not only makes oxygen and oxygen and energy, also releases some water vapor. So that water vapor will then get evaporated into the air, just like regular water. It's just this, it's a special name, transpiration. Guys, don't get transpiration or plant sweat confused with dew on the grass. So right now the grass is wet. It's not because the plants are releasing the water. It's because of condensation. We learned that a couple chapters ago. Condensation is when warm air touches a cold surface, and because cold air can't hold as much water, the water drops out of the air in the form of dew because the water hit its dew point. So just don't get those two concepts confused. Then number 3 was up in the clouds, and we learned that the clouds form through condensation. And then I don't think I really needed to define precipitation. Hopefully you will always remember that one. The last two, so runoff and infiltration, may have been the new vocab words to you. So let's go back to the picture real quick. So runoff is number 5. What is the water doing in number 5? So it's running off. What is that? What do you think that is? A river or stream is an example of runoff. So is any time water does not soak into the ground. For example, flooding is one time this happens. So the water can't soak in for whatever reason, and it runs across the surface of the earth. To be honest, even a puddle is considered runoff, even though it's not moving, but it's not soaking in. And then what's the arrow with number 6 doing? Yeah, it's going down. What's the water doing if it's going down? Huh? It's called infiltration, but before I put that word up there, what would you have called it? Absorbing or potentially just soaking into the ground. So officially those definitions are up there now. Runoff is the water that flows over the land into a larger body of water. And infiltration is when water soaks into the ground and becomes groundwater. So for those of you who rely on wells, infiltration is your friend. You need water to soak into the ground to become groundwater in your well. So I know I didn't spend a lot of time on the water cycle, mostly because you know it already. Just make sure you don't forget the 2 new words. So for second period, I'm sorry I rushed you through this. I ended up doing these vocab words with all my other classes after the test. We had plenty of time. So that is why I did rush through them today. I'll let you guys finish those up and then we'll move on. So unfortunately, it looks like it's supposed to rain later today. What happens to the water after it rains? What are some things that can happen to water after it rains? So it's raining, rain stops. One thing that can happen is the water can soak into the ground. What's another thing that could happen to, let me actually rephrase this, any precipitation, not just rain. So one thing is it could soak in. What's another thing that could happen to the water? If it was snow, it would just stay on the ground. That's perfect. Another one is it can evaporate. Can you think of the fourth thing that could happen? If it doesn't soak in, it doesn't get stored as snow, it doesn't evaporate, it could run off. You got it. Those are the four things that can happen to precipitation. So this is at the top of page 2. All right, now that it's rained and we want that water to evaporate, or anytime you want water to evaporate, one thing that I like to talk about is, have you guys ever hung clothes outside on a line? Some people do, some people don't. I do it all the time. I'm kind of a freak about it. Where's the water go from my towel that I have hanging on the line? Where does that water end up going? So it's either going to evaporate up into the air. If it drips off the bottom, it's going to soak into the ground. You got it. So let's talk about evaporating. What are some conditions that will cause water to evaporate better? One, if it's warmer. I don't hang clothes out in the winter because it's not warm enough. But what does that have to do with water evaporating? Why does water evaporate better when it's warm out? Because hot air can hold more water. The warmer the air, the more water it can hold. So warm air has more room to take up the water on my towel that I hung out. TJ, what's another one? If it's dry out, there are days over the summer when it's just too gosh darn humid to dry clothes. So I need warm, dry air. There's a couple more things it can do to encourage water to evaporate. Think of the clothes on the line. Air moving. How does wind help dry my clothes? Why? You're right, it is true, but that's not why it causes water to evaporate better. So if the air didn't move, what happens to the air around my towel? It gets filled with water. If the air wasn't moving, the air that was right next to the towel would get filled up and it wouldn't have room to hold more water. So when the wind blows, it's constantly pushing, I guess what you call new air towards my towel so that my towel is constantly being hit with new, drier air. Now there's one more thing, and this one I don't think you can get from thinking about laundry. How about in your basement? Anybody ever had a basement get water in it and you have to get rid of the water? No? Well, you guys are lucky if you don't. So what are some things you do in a basement to get rid of water? A dehumidifier. What does a dehumidifier do? So it makes the water more dry. So we already covered that one, but you're not wrong. What's another thing you might do? Okay, pump it out. That one doesn't count, but you're right. You're right that we're not forcing the water out. How about the rest of you? Colton, Sean, and TJ, but the only people I've heard from today. Oh, years that count. All right, how about this example? Let's forget the basement. Here's 40 ounces of water right here. If I leave it like this, will it evaporate? None?
It will.
It will a little bit, but will I notice if I left this here like that and came down back tomorrow? Would I even notice? Maybe, but probably not. What could I do to make that water in my water bottle evaporate faster? The 40 ounces of water in that bottle. What'd you say? Put it in the sun, that would heat it up, absolutely. What's another thing I could do to make that water evaporate faster? Spread it out. What if I dumped my water bottle in here? And I left it, I didn't soak it up with paper towels. Would it be dry by tomorrow? Probably, depends on how big my puddle was. But the more you spread water out, the faster it will evaporate, because you need more surface area. Right now, only about that much water is exposed to the air. So that's the only place water can evaporate from, is where it's exposed to the air. If I spread it out over the whole room, you ready? Oh, I finally got some people's attention. So if I spread out the water, in other words, dump it all over the room, it will evaporate faster. Yeah, you ready?
Yeah.
Was I? Here's how to increase the rate of evaporation. I better put the top on this before I spill it. So I don't know if we've really talked about anything that's new to you yet. In that space right next to where we just wrote, we're going to do one thing that, oh, some of you have drawn pictures in it. Hopefully, you have some room. Does anybody need a Post-it note to put in that space? I can give you a Post-it note to put over there. So right next to where you just wrote, this one might be a new term to you, the water table. You guys ever dug a hole and reached water?
Yeah.
Where can you dig holes and reach water? A beach. You ever tried to dig a pit on the beach?
Yeah.
And you get to the water? You have reached the water table then. Do people dig holes around here and reach water? Not very often, but a lot of you have one of these. A well. You dig a hole deep enough around here, which around here, the deepest holes around here are typically wells. You get to the water table. The water table is officially the boundary between where the ground is saturated and where it's unsaturated. Do you guys know what I mean by saturated? What? Wet, yeah, all wet, all filled up with water. Now, sometimes this water table is higher up in the ground, so you don't have to dig very far. And sometimes it's really deep in the ground and you have to dig for quite a ways. Have you ever walked in a yard or in grass and felt the water squishing beneath your feet? Like this past couple of weeks? What's been happening in this past couple of weeks that's making the ground squishy? Lots of rain. So when that water table, when your feet are literally squishing, when you walk in your backyard, you can feel the water right underneath your feet. That is because there's been so much rain that the water table has moved up. It's closer to the surface. All right, let's just knock out a few more vocab words and be done for today. So let's do 5 more vocab words. Would you guys rather look these up in a textbook or do you want me to put them up here for you? You sure you guys really don't want to do any work?
Oh.
Lazy bums. What if I don't want to do any work?
Writing stuff down is still technically work, you got it.
Well, okay. All right, we'll come back to those questions for homework. What do you think permeability is? Page 4. If something is permeable, hey, permeability is the ability of water to be able to flow through the soil or other material. So we're on page 4. Thank you. Oh yeah, grab a new pen. Can you give me some examples of permeable materials? Doesn't have to be sciencey, it can be real life things. Okay, paper. Yeah, you get it wet enough, water's gonna go through. Can you name something else? Dirt. Sand. Okay, air. What? Stones. How about clothing materials? Which clothing materials are permeable?
Meshy one.
Okay, meshy ones, even t-shirts, sweaters, sweatshirts. Water will get through them. How about a colander? Okay, where you drain your macaroni and cheese noodles. Okay, a slotted spoon, yep. Those are all permeable. They allow water to get through. The next word is permeability rate. Put your thinking caps on. What do you think that one is? Yeah, permeability rate is how fast water can flow through. So some materials are more permeable than others. Like that colander where you dump your macaroni and cheese noodles into, has a high permeability. The water can soak through really fast. The next word is impermeable. What do you think that one means? Okay. Permeability means, or impermeable means water cannot go through the surface or through the material. Concrete, pavement, tightly packed soil. What do I mean by tightly packed soil? Soil that you like packed down. Can you guys give me an example of a place where there's soil that's packed down? What? Underneath the building, is that what you said? Absolutely. Where else? How about a playground? You ever been to a playground that has some tightly packed soil? What location are those that have tightly packed soil on a playground? Where, give me an example of where everybody walks on the playground. Paths, that's one.
Bottom of the slide.
Bottom of the slide, why is there tightly packed soil at the bottom of the slide? Okay, so yes, but why is the soil tightly packed at the bottom of a slide? Because every single person that goes down that slide has to land pretty much at the same exact spot. So all those kids that come out during recess, they go down the slide, they hit. They go down the slide, they hit. Every day that soil gets packed in. And what is also usually at the bottom of the slide? A puddle. Why is there a puddle at the bottom of the slide?
Water collects there, has nowhere to go.
Why can't it go through?
The soil's packed.
Because the soil's too tightly packed down. Same with at the bottom of the swings, underneath the swings, there's usually, if there's a puddle, that's where there's gonna be one again, because every single kid who gets on the swings basically has to get on at the same spot, so that soil gets packed down really quickly. What? That's why I said most, but to get on, you at least have to stand in the same spot. Okay, maybe you do gymnastics and you get up through. All right, and then 2 more words. The next word is porosity. What do you hear in porosity? Pores. And what are pores? Even the ones on your face. Holes. So porosity, what do you think porosity is? Okay, so it's not necessarily the amount of holes, but it's the amount of hole space. So we could have one really big hole or a bunch of teeny tiny holes. It's just adding up how much whole space there is. And the last word is capillarity. What do you hear in that word? You hear capillaries, which do you remember what those are? Yeah, they're the really, really small blood vessels. Like if you are able to see little veins in your eyes, those are capillaries. Teeny tiny blood vessels that kind of goes along with this. It's not, oh, sorry, here's porosity. It's the amount of hole space. All right, capillarity is, does not have to do with blood vessels, but it does have to do with small. And we'll talk about that tomorrow, but capillarity action is the upward movement of water through tiny pore spaces. Have you ever seen water go up anything without like a pump or something pushing it up? No, okay, we'll demonstrate that tomorrow then. All right, now that you've got those vocab words, your homework will be questions 1 through 9, so pages 2 through 4. Put that up here. So those are all Regents questions that have to do with water and the water cycle and all that good stuff. But what I do want to go over next is the test. So 1, I want to give you the right answers. 1, so you can check my work because I could have always made a mistake. And 2, because I think a few of you might want / need to do test corrections. So let me pass out the test correction papers to anybody who wants them, who wants the test correction paper. Remember, it's guaranteed 10 points higher. I will even take a 100 to a 110 if you redo the test. So remember, I don't just give you 10 points. You have to do the paperwork and retake the test. Anybody else?
That's 80 times.
All right, anybody else after TJ wants this? Of course, darn it, I'm out of papers. TJ, can you not write on yours? Oh, wait, I got one more. TJ, do you mind just doing yours on a separate sheet of paper since you don't have many?
Okay. Thank you. On next time.
No, you said less. All right, if anybody else wants test correction papers, I'll get them more, some more printed up. All right. Okay, test correction. Okay, are you ready for the correct answers first? Always a good idea to correct your work, as I am not perfect. Speaking of not being perfect, for those of you who skipped question 1, shame on you for forgetting the number 1 rule of earth science and reading all the words. Number 1, the answer is C. 2, B. 3, A. 4, D. 5, A. 6, A. 7, B. 8, D. 9, B. 10, D. 11, C. 12, A. 13, C. 14, A. 15, B. 16, D. 17, C. 18, B, 19, C, 20, B. 21, oh, this one killed me, guys. So 21, sorry, let me see if I can get a blank one going up here. Oh, I might not have a blank. We're boiling water. The word said it's being heated. When water gets heated, we've talked about this quite a bit, when you have macaroni and cheese being made. What kind of energy transfer is that? Radiation, conduction, or convection? Convection. So you need to have that circles where the warm water is going up and the cold water is going down, which lots of you have. But you are missing one key concept. On your stove, where is the heat? Underneath it. How much? Where underneath it? All of it. On your stove, when you put your pan down, the water gets heated up on the entire bottom. Is that happening here? No, there is only one little tiny heat source. So where is the water going to be getting warm? Right above that heat source. So with this, you did have to have the, I don't want to write on this because that was my last copy, right on the board. So you did have to have the arrow going up directly over the heat source. And then the cold water from the top would be flowing down. The key was having the up arrow over the heat source. And if you did not have it that way, for example, a lot of what I saw was unfortunately this. The water is not going to sink over the heat source. That's where it will rise. So a lot of you had the right concept that it was convection, but you did have to have that up arrow directly over the heat source. All right, on to number 22 was A, 23, D, 24, D. Oh, Riley, I'm sorry. I was wondering why you were writing on the side of your paper. 25, that one's C. (26) also threw a bunch of you off. The key with 26 is warm air rises, cold air sinks. So this is a summer day. The warm air is going to rise up to the attic and then escape through the roof vents. So you needed to have the one that had the warm air going up. What? B, sorry. 27, I did switch that to the season instead of the actual day. So the most ultraviolet radiation will be in the summer. If you were wondering what the actual day is, it is the first day of summer, which is June 21st or 22nd, depending on the year. Now this next one really blew a lot of people's minds. I wanted the altitude of the noontime sun on the X. That's this column. And then I wanted the hours of daylight on this, that's the Y, so that's this column. So you could have done a couple of different things. I saw some people giving a rough scale on the X-axis. So the X-axis, the biggest number would have needed to be a 70.4, and the smallest number would have been 24.4. The Y-axis, the smallest number would have been 9, and the biggest number would have been 15.3. And then you could have plotted them out. I also just saw a whole bunch of people say, oh, this goes up, then down, and then, or sorry, goes up and then back down. But then you didn't see what this also does. This also goes up and then back down. That is not a U shape. What that is when the altitude gets higher. So when the altitude goes from 32 to 70, what happens to the daylight hours? that also goes up. When we go from 24 up to 70, that also goes up. Your line should have just been a nice, perfect, direct relationship. When altitude of the noontime sun goes up, so does the hours of daylight. There should be a whole bunch of questions. Which ones would you like me to go over? Yeah, Nick? Oh, you just need the answer? B. I'll actually go over that one as well, because that one I think was a somewhat of a trick question. The correct answer is B. The reason I think it was tricky is because I asked for the stratosphere. A lot of people either thought about the whole atmosphere, and so you would have said it decreased, increased, decreased, increased. Or often I've asked that same question about the troposphere on the homework, but the stratosphere goes from -55 at the bottom to 0 degrees at the top of it. So that is an increase in temperature only. What other ones should we go over? I will tell you, I know a whole bunch of people got number 2 wrong. And most people who got it wrong put D. Guys, how much sunlight does the equator, EQU, get? Equator, EQU, equal EQU. The equator will always get 12 hours of daylight and 12 hours of darkness. Are we currently getting more or less than 12 hours of daylight here in Buffalo? We're getting more. The sun rises before we leave for school, so sometime before 7. It sets sometime after 8. We're already getting more hours of daylight than the equator does. So the equator does not receive the most hours of daylight, but they do receive the most direct, or in this case, I did change it up and use the word perpendicular. Hopefully you guys know that perpendicular makes a 90-degree angle. Also, too many people got 5 wrong than should have. This is actually the 3rd time it's shown up on a test. Remember that the atmosphere is made out of air, the lithosphere is made out of rocks, and the hydrosphere is made out of water. So air is less dense than all of those. Rocks are more dense than all of those. So put them in order, you get answer A. Atmosphere less, lithosphere most. Any others you guys want to go over? We still have 5 minutes. Hey, you have no more questions. Corrections and retakes will be due a week from today. So you have until Tuesday, the 30th.